Hello and welcome to another video. In this one we're going to be talking about lazy imports, PEP 8.1.10, that's coming to Python 3.15. And I know a few times people were like, hey, they do a lazy imports video. And I was like, no, just put it in the release video. It's fine. It'll come eventually. I've decided that I'm doing this one early. It'll also be in the release video, but I'm specifically doing this early because I've made a terrible thing that I will hopefully be showing you in next week's video. But anyway, let's jump into it. We're talking about spoilers, we're getting a little ahead of ourselves there. We're talking about PEP 8.1.10, which is a way to add explicit lazy imports to Python. The way this functions is by adding a lazy keyword in front of an import statement. It can only occur outside of functions, and it can't occur for star imports, but otherwise it allows you to defer a import of a module or a from import from a module. Note that when you defer a from import from a module, the whole module is still imported. It's not a way to like piecemeal get parts out of an object, but basically it defers that until later. And kind of the way that it works, I can show you very briefly how it works. And then I'm going to show you why you would want to do this, as well as some practical examples, some tools that you might use to find candidate imports to improve here. And some kind of pitfalls with how it works. There's some rough edges to look for, but it's kind of going to help you solve three main problems. So we'll talk about those when we get to it. Okay, but I'm using 3.15 beta 1 right here. This I believe landed in like alpha 5 or something like that. So any new enough version of Python 3.15, specifically I'm getting this one from Dead Snakes, which is well, you can kind of tell by the naming here, but I maintain Dead Snakes, and so this is where I've gotten that from. Anyway, Python 3.15. You can use from, so normally an eager import, you would do like from JSON import loads, for example. But if we put the lazy keyword in front of this, we get a lazy import here. And the way it kind of works is if we look at globals, which is a shortcut to the dictionary that things are stored in. This is put a lazy import object inside globals. We can actually sneakily access it here without triggering the loads from globals equals this. We can kind of inspect this little object here. Oh wait, nope, too late. we've already triggered the loading here. But basically, this lazy import object, I don't remember how to get it without triggering the loading. But anyway, that's a different detail. This loads object here is a lazy import in that it has not been, it's sort of been deferred. And when you access this function, it will load the module and then load the attribute from the module. Or in the case where you do like lazy import async IO, this is an entire module here rather than a from import here. And so you can see somewhere in here, yeah, we have a lazy import that's the entire module rather than just an attribute of the module. And so what this allows you to do is take heavy imports in your program and defer them to later. Or we'll see two other uses later. But we're going to start by talking about heavy imports first. And for that, I think I don't know, what's a command line application that I can show this with? Let's do my text editor Babby, for example. Although this probably isn't a great example because I don't know how often you would query Babby for its help. But let's talk devm VM Python 3.15 so we can get a development environment using Python 3.15. And that'll allow us to muck around with the code and kind of show what I'm talking about here. I'm actually going to say no for now. And just to show that this works, actually I should make sure that this works because I know that there were some funny bits. Okay, yeah, Babby 1.7 using Python 3.15. Okay, cool. So one thing that's kind of marketed with PEP 8.1.10 is to defer imports to make simple operations with command line tools a lot faster. And one of the like common things that you're going to do for a command line tool is ask it for its help. And so we could say, you know, Babby help, and this prints out a help here. Now, granted, Babby's help is pretty straightforward. There's this, actually, I should probably hide this option because it's really only useful for internal development of Babby to do performance testing. But anyway, it takes file names. There's a help. That's what you need to know. But you might complain like, oh, this help takes a little bit to show up. It's not as instant as it could be. And if we run my little helper here, how are we going to do this? Because we don't actually want the output. Babby help. We'll just write all of it to def null. Let's run it 20 times. And this will kind of give us a sort of benchmark of like, how long does Babby take to run itself? 77 milliseconds, pretty fast, to be honest. Like, I probably wouldn't be trying to optimize Babby specifically here, but in theory, we can do better by deferring some of its imports. I happen to know that it imports a regular expression library. It does some like compilation of some regexes, and like there's some fiddly bits that might take a while to load here. There also might be some modules that are surprisingly slow, such as, well, I happen to know like import lib metadata imports the email module, which has a bunch of parsing code, and that can be pretty slow. So let's try and defer some of these imports and see if we can improve this. Now, before you sort of jump into deferring imports, what I usually recommend is trying to profile your imports and figure out which ones are slow to begin with. Python includes a thing out of the box to do that, but I find that its output sucks. Let's see, -c import this. I find that its output is kind of bad. Like it's not obvious from reading this output, one, like what's the slowest stuff. Yeah, it does give you this like self time and cumulative time here, and you kind of see like this is a big number, but I find, at least personally, that this output isn't that great. And so I wrote a tool to improve on this, and I have called it import time waterfall. You can pip install import time waterfall, and it gives you a little bit better visualizations here. So pip install import time waterfall. And this isn't just a giant plug for this library, even though I think it's pretty cool. And if we run that same thing here, we get kind of a little bit better output here, where you get like a in order structural representation of how the modules actually execute, whereas Python's is in reverse order, and like you kind of have confusing time here. But this isn't the really cool part about import time waterfall. It can output to a graph format. I specifically used the HTTP archive format because at the time I wrote this, there weren't, well, there probably were other better ones to visualize it in, but this one worked. --har. We're gonna copy this clipboard. Oh, what is the command I'm thinking of? Xclip. What's the copy to keyboard? Why can I not? I feel like it's muscle memory at this point. Copy to clipboard Linux. I literally ran it before this. Xclip. Oh wait, I didn't even get to this. Xclip Celsi? Yeah, that sounds like a thing. I didn't even get the Google search off in time. Okay, but you can take this output here and use an HTTP archive viewer, such as this one here. And where, oh, did I not click on the viewer? Yeah, I didn't click on the viewer. And you can paste in here a giant JSON blob, and it gives you kind of like a waterfall view of how your imports run. Now, granted, the timescale here is fudged because it's actually on the like microsecond scale, and HTTP archive only supports like millisecond scale. So this is all like fudged by some multiplication factor, but it kind of gives you a visualization of like which of your imports are slow. So like you might notice here, babby.screen is, you know, the gray time is self time, the purple time is its dependencies. So you can see like it pulls in a lot of dependencies here, and so potentially like that might be a module you want to defer. If you're just looking at things that are like particularly slow, you might say like, oh, subprocess importing locale is actually, you know, this locale module takes a lot of self time here relatively, if you're looking at gray things. But this might give you some ideas on like what stuff to look for and like which modules to target here. It looks like my hypothesis was not quite correct here. I was expecting this module, Oniguruma, to take a while because it's a kind of hefty C extension. But it looks like I'm not quite correct here. The other idea that I had was the highlight module. Oops. Oh, I didn't mean to close the tab. Ah, dang it. We'll re-render it. Highlight module. Yeah, this one does compile some regexes, so it might be slow. But we're gonna actually show this in a different way by just, we're just gonna make every import in the main module lazy, so we can kind of see some of the effect of this here. So if we open up, we'll actually use Babby to edit Babby. And I am just going to replace from or import, but probably not, well, I know we can't rewrite future imports, so we're gonna do a little negative look ahead there for future, and capture group all this, and we'll replace it with lazy this. And so this should allow us to replace all of our imports here. So if we make all of our imports lazy, and you might ask, well, why not just make all of your imports lazy? That was actually PEP 690 was the just make everything lazy. And there was a lot of arguments about that, and it ended up not happening. I don't remember the specific reason why, other than I'm pretty sure there's some complexity with making everything lazy that makes things harder to reason about. Now, I'll actually show you like one pretty bad pitfall with lazy imports later. Anyway, it has to be explicit. So we're going to explicitly mark all these imports as lazy, and this will kind of give us the best case of like making everything lazy here. And we'll notice here that, wow, we managed to shave 40 milliseconds off of the help of Babby. Probably not significant and probably not worth the complexity here, but it's kind of just to show you the idea of like, if you defer some imports, you may be able to squeeze some performance out of your help here. Now note that I tried the same thing with a few other tools that I maintain, and particularly Precommit, which I know spends a lot of time importing PyYAML at its startup. And sometimes you'll need to change some code if it like for instance, Precommit, let's see. Actually, let's just show you the file, lib precommit YAML. So for instance, in this, like I was hoping I could just lazy import YAML here, but because at the module scope I'm accessing an attribute from it, this will trigger the lazy import to import eagerly. And so you may need to adjust your code slightly to make these lazy imports actually do what you want them to do. And so again, like make sure you're profiling when you're doing this and make sure you're actually making a difference, because it's all too easy to have a lazy import that isn't actually lazy. Honestly, there should probably be some like heuristic where I don't know, maybe you get a warning if like you mark an import as lazy, and as the module itself is loading, you get like a import warning if that lazy module gets eagerly imported. That would be kind of a cool feature. Python doesn't do that yet, but it's, you know, a little wish list idea. Maybe me grumbling about it in a video will get somebody to get nerd sniped and implement it. Anyway, so that's lazy imports, the first part of this, which is to defer slow modules. Kind of the ideal things are for things like dash help, dash version, or, you know, some sort of other usage in command line tools. This can also be really useful in like if you deferred all your imports in like test suite discovery, because you know, that can be really slow if you have to import your whole code base, or kind of other things like that where you have hefty chunks of modules. There is an option to enable lazy imports everywhere if you really want to do that, and in a lot of cases it'll work, but sometimes it won't. More on that later. Smile. And you can, I forget what the option is, help X options, grab lazy. Yeah, so you can do Python 3 lazy imports equals all, and let's say we did babby.main here. This is deferring every import in Babby, and I guess we could probably say best of 20 and do the same little exercise here where we say, oh, look, I guess we can squeeze a tiny bit more of of performance out here, though I don't know that you would actually want to do that. I guess the other nice thing about not importing modules is they don't end up resident in memory, so you can also save some memory savings here. But anyway, so that's the first use, deferring slow modules. Let's talk about the second use, and this is actually also going to touch on the third use at the same time, because I happen to know the example in Babby for this is specifically for the third thing, which is if you have circular imports. Let's actually discard everything. If you have circular imports, yeah, I guess we'll do that one first. Well, no, okay. We can, oh wait, these are all for the same reason. Yeah. So if you have circular imports, lazy imports can sometimes help you with them. So for instance, this is a circular import here. The other reason, and I guess this is kind of two of the same thing at the same time, which is if you have imports that are just for type annotations, you're kind of wasting your time waiting for those to import when you could be deferring them till later. So for instance, this screen here is only used in a type annotation. Like that's the only reason this is imported. And so I put it in a type checking block. It's also a circular import, so I've also put it in a type checking block for that reason as well. And lazy imports kind of solves both of these at the same time. It can allow some circular imports to be successful. So for instance, if we, let's actually do it without the lazy import just to show you that it's broken. Actually, kind of a cool fun fact here. This is actually probably my favorite thing that I've ever done to Python. this error message here, most likely due to a circular import, I added that. So this chunk here, I added that to Python because it's a very common mistake that people make as beginners. But anyway, you can see here we have a circular import, and we can solve this in this particular case by making this import lazy. This kind of has two effects here. Like one, it's lazy so that the type annotation doesn't actually need to resolve this module in order to have the type annotation. Obviously, if you query the annotation, it'll trigger the import. But also, this avoids the circular import. So I'm actually doing uses 2 and 3 at the same time here. I couldn't find any good examples where I didn't have those 3, but you can see here now if we run Babby again, it's able to start, and that import was actually deferred, and the cycle was able to be resolved here rather than having to eagerly import that. Okay, so 3 reasons to lazy imports. 1, performance and memory. 2, type annotations that you probably don't actually need to import the modules for. And 3, it can solve some import cycles. So those are the 3 reasons. Now I want to talk you through some of the pitfalls, or at least one pitfall that I feel is pretty bad and like kind of makes me nervous about using this feature. Although you can kind of solve it, sort of. And that is that lazy imports, since they are deferred, they don't actually check the validity of the import as it happens. And you might be able to imagine, like, I don't know, if I do lazy import some module that we know doesn't exist, it succeeds as I run it. It also, you know, we're able to see it inside globals here in the same way. Like this name is imported, and only when we try and access it do we actually get the import error here. And this makes me a little bit nervous because you could write an import in code that's like poorly tested, or you're like, oh, don't worry, this is just like a one-off script, bro. It's fine. Like, trust me. Like, you know, I checked all the dependencies. They're surely fine. And so you might run into a situation where the code looks like it works and you don't really notice until you run it in production or in an environment with different dependencies, or any sort of situation like that where you're going to end up with this runtime error as opposed to like finding this earlier on in development or otherwise. So that can be a little bit spooky. But I don't really know how this would be done better, especially when you think about from imports. Like if you did from JSON import loads 2, there's obviously a typo there, and like it meant to be from JSON import loads. But to know that this attribute actually exists in the module, you'd have to eagerly import it. And so it wouldn't really make sense to make like, you know, module discovery be eager, but attribute resolution being, you know, lazy. And so like I kind of understand why this design flaw is here, and I don't really think there's a good way to fix it. But you know, what I would recommend is if you're running, or if you're worried about this particular problem, like make sure you have good test coverage, make sure that your development environment matches your production environment in terms of dependencies and such, and use a type checker. Like a type checker can help you find, you know, typos and things like this, especially if you have type dependencies or a good version of typeshed available. It'll help you with these problems before you accidentally run into them in production. So that's kind of like the big pitfall here. Now, I did want to mention one other thing, which is kind of a funny side effect of how lazy imports was implemented and also utilized in the standard library. Now, from reading the issue tracker, I believe this will actually be fixed by the time Python 3.15 lands, but it didn't end up in the beta. If we look at that option again, X options, you'll notice that you can turn off lazy imports. You can set them to none. All, none, or normal as 3 different options here. And the tricky part here is if you are using lazy imports to solve cycles, and then you also have a way to turn them off, that cycle is going to get broken. And so you're going to have issues with any code that uses lazy imports. However, I believe this none option will not exist when Python 3.15 lands. To give you an example of this, I'm on kind of an older version of Python. In this particular version, Python itself used lazy imports to solve a few import cycles, and you'll notice that, you know, we're able to start it just fine. If we use that option from before, x lazy imports equals none, disabling lazy imports, those few places where there are import cycles in the standard library result in it crashing. And so Python is actually completely unusable without lazy imports enabled in this particular version. Now, granted, they ended up fixing this in a later version, and this is planned to be removed by, or at least I think it's planned to be removed by the 3.15 final. And so while this is, you know, kind of funny that it's an issue now, it should be solved by just not having this in the end. Which, you know, one could think like lazy imports equals none is kind of a nice feature to see, like, do my imports work when they're eager? Maybe perhaps solving that import of the unknown module from before, but it won't be an option. So, and here's kind of a funny side effect of why it won't be an option. I should talk about one more thing with lazy imports, which I forgot to mention before, which is there's another way to turn them on. If you want to turn them on in a way that's compatible with older versions of Python, and that is to set a double under lazy modules. I don't know. I feel like people aren't going to use it, but double under lazy modules before you import things. And so this is equivalent to putting a lazy keyword on this here. I think this is kind of gross because a lot of import sorters, as soon as they see code, they're going to ignore the rest of the file. But I can't really think of a better way to do this, so it kind of makes sense. But this is another way to turn on lazy imports for forward compatibility. This would allow you to run this code in Python 3.15, where this module is lazy, but in Python 3.14, it would just ignore this assignment, it would do nothing and continue onwards. Anyway, I think that's all the things that I wanted to cover with lazy imports, and I'll show you a real fun thing about lazy imports hopefully next week if I remember to record the video. But thank you all for watching. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.